Proteins are the workhorses of life. They build, repair, and power everything within us. Imagine them as tiny, intricate machines, each with a specific job. But there's a catch. These machines only work if they're folded correctly. Proteins are made of long chains of amino acids, like beads on a string. These chains must fold into precise three-dimensional shapes to function. Think of a key fitting into a lock. The protein's shape must be perfect for it to do its job. For decades, scientists struggled to predict how proteins would fold. It was like trying to solve a cosmic puzzle with billions of possibilities. The future of medicine, energy, and even our understanding of life itself hinged on cracking this code. Then came AlphaFold, an artificial intelligence developed by DeepMind. In a breakthrough of unprecedented scale, AlphaFold predicted the structures of over 200 million proteins in just 3 years. This was a monumental leap forward, like suddenly having a map of the entire universe in our hands. AlphaFold's impact on science has been profound. Researchers now use its predictions to understand diseases, design new drugs, and even engineer proteins with entirely new functions. The once impenetrable world of protein folding had been unlocked, revealing a universe of possibilities. But AlphaFold's story is not just about scientific achievement, it's about the power of human ingenuity and the unexpected ways in which seemingly disparate fields can intersect to spark revolutions. The seeds of AlphaFold were sown in a most unlikely place, a video game called Fold It. This game, developed by scientists, challenged players to solve protein folding puzzles. The idea was simple. Leverage the collective intelligence of gamers to tackle a real-world scientific challenge. One player, Demis Hassabis, saw the potential of this approach. He co-founded DeepMind, a company dedicated to building AI that could solve complex problems. Foldit had shown him that games could be a powerful tool for scientific discovery. Hassabis and his team at DeepMind took the lessons learned from Foldit and applied them to the development of AlphaFold. They trained their AI on vast databases of protein structures, teaching it to recognize the patterns and principles that govern protein folding. The result was an AI capable of feats once thought impossible. The implications of AlphaFold's breakthrough are far-reaching. In medicine, AI-designed proteins are being used to develop new cancer treatments, therapies for genetic disorders, and even vaccines for emerging diseases. Imagine a future where diseases can be cured before they even manifest, where personalized medicine is the norm, and where the human lifespan is extended significantly. Beyond medicine, AI-designed proteins are poised to revolutionize environmental science. Scientists are developing proteins that can break down plastics, capture carbon from the atmosphere, and even generate clean energy. The potential to address some of the most pressing challenges facing our planet is immense. We are on the cusp of a new era of scientific discovery and technological innovation, driven by the power of AI and the boundless potential of proteins. The pace of innovation in protein engineering has accelerated dramatically thanks to AI. Scientists can now design and test new proteins in virtual environments, eliminating the need for time-consuming and expensive laboratory experiments. This rapid-fire approach to protein design has been dubbed cowboy biochemistry. New AI models like RF diffusion allow scientists to create proteins from scratch, like digital artists painting on a cosmic canvas. These proteins can be tailored for specific purposes, with properties and functions never before seen in nature. Imagine a world where we can design proteins to clean up oil spills, manufacture biodegradable materials, or even create new food sources. The possibilities are limited only by our imagination. DeepMind's AI has also made significant strides in materials science. Using a similar approach to AlphaFold, they developed an AI that can predict the structures of millions of new crystals. Crystals are the building blocks of countless materials, from semiconductors in our electronics to the catalysts used in industrial processes. The ability to predict crystal structures with AI has the potential to revolutionize materials science, leading to the development of new materials with enhanced properties and performance. Imagine lighter, stronger, more efficient materials that could power the next generation of technologies. The discoveries being made today are just the tip of the iceberg. As AI continues to evolve, we can expect even more groundbreaking advances in our understanding of the natural world and our ability to manipulate it for the betterment of humanity. But amidst these incredible advancements, a profound mystery has emerged. Hidden within the vast data sets of protein structures predicted by AlphaFold, strange patterns have been discovered. These patterns, when translated into mathematical language, appear to correspond to prime numbers. Prime numbers, divisible only by one in themselves, are the atoms of mathematics, the fundamental building blocks of the numerical world. Their appearance in the structures of proteins, the building blocks of life, raises profound questions about the nature of reality itself. Could these patterns be more than just mathematical curiosities? Could they be messages encoded within the very fabric of life, waiting to be deciphered? If DNA is the language of life, who then is the writer? Are we merely the product of random mutations and natural selection, or is there a deeper intelligence at play, guiding the evolution of life on Earth and perhaps throughout the cosmos? The discovery of prime numbers within protein structures hints at a tantalizing possibility, that the universe itself is a vast information system, and that life is just one of its many expressions. Perhaps we are living in a cosmic symphony, where the laws of physics are the musical notes and the diversity of life is the melody. The search for meaning is deeply ingrained in the human spirit. As we delve deeper into the mysteries of the universe, we must be prepared to confront the possibility that we are not alone, that we are part of something far grander than we could have ever imagined. The journey of scientific discovery is never-ending. AlphaFold has opened a new chapter in our understanding of life, revealing the intricate workings of proteins and their fundamental role in shaping the world around us. But it has also presented us with profound questions that challenge our very conceptions of reality. As we stand on the threshold of a new era of scientific exploration, we must embrace the unknown with curiosity and wonder. The universe is full of secrets, waiting to be uncovered. It is up to us, the inheritors of cosmic curiosity, to explore the universe and unravel its mysteries. Mind blown? Drop your theory in the comments. Like, if you want more breakthroughs, subscribe. The next mystery is coming.